Okay, this question's about the alpha particle, alpha scattering experiment. So the two scientists were Geiger and Marsden. Geiger's got the Geiger counter named after him, under the supervision of Ernest Rutherford. And this is basically the experiments where they discovered the nucleus. So they found that when they fired the alpha particles at the thin gold, a very small number reflected directly back. Some were sort of partially deflected, so their direction changed slightly. Most of them just went straight through. Okay, so what did that tell us about the model of the atom? So previously it was the plum pudding model of Thomson. So how did they have to adapt and change the model? So they discovered that there was a tiny positively charged nucleus where nearly all the mass is concentrated, and they also found that most of the atom is just empty space. So only the small number of alpha particles that came very close to this tiny nucleus were deflected or reflected right back, and then most of them were just travelling through the empty space sort of between the gold nuclei. Explain why the previous model needed to be changed. Well, the previous model would have predicted that all of the alpha particles would have been able to just travel straight through. There wouldn't have been anything dense enough to cause the alpha particles to actually be reflected directly back. But we don't need to go into quite that detail. We can just say that the previous model could not explain the new observations. Okay. The second half of this question is doing some calculations. So the first one is just calculating a volume, so the volume of a classroom. And to calculate volume, you just need to multiply the three dimensions together. So the volume is going to equal 3 meters multiplied by 8 multiplied by 8 again, which should give you 192 meters cubed. And then we've been asked to calculate the mass of the air in the classroom. We've got the volume, we've been given the density, and we need to find the mass. We're just going to double check the units. So the volume here is in meters cubed, and the density is in kilograms per meter cubed, so the units are good. Let's put that into our equation. So the density equals mass over volume. 0.012 equals mass over 192. And then to solve this, we're just going to multiply both sides by 192. So we get m equals 0.012 times by 192, which should give us 2.30 kilograms.